Welcome to the third part actually, of this video on my bookshelf. Let us now do the books that I'm currently working through. The first book is here, How Mathematics Happened, the first 50,000 years. So this is basically everything of mathematics before the Greeks. That means it deals with the birth of arithmetic in hunter-gatherer societies, pebble counting, Babylonia, Maya. We see here the Egyptian in the Valley of the Nile. We see here Babylonia. And then finally, the early stages of Greek mathematics. It's an extremely good book, extremely beautiful book. If you want to learn about the history of mathematics from chronologically, this is the book you want to start with, because it really contains everything you need to know before you start with the Greeks. You don't really need too much prerequisites for this. It's fairly simple. The second book is The Science of Radio by Nahin. Nahin is one of my favorite writers. He's very good. And this deals with how the radio works exactly. So it deals with the mathematics behind the radio, and it deals with how the radio is constructed, how the circuit is constructed, and how everything works. I think Nahin used this as a kind of as part of a course for electrical engineers, to kind of get everything, get some application down, instead of just circuits without application and people seeing the application only much later. This book really shows everything in one course, starting from circuits, starting with the math, starting with Fourier theory, all the way to being able to construct or deconstruct a radio. Very good book. Then we have here a history book on the development of logic. Look at the size; it's a very thick book. And this basically is the history of logic, starting from scratch to all the way to the end. So let's see what we have here. It starts, of course, with Aristotle. Aristotle is, of course, the one who started logic in the first place. It has Stoic logic, it has medieval logic, it has Renaissance, and then finally it ends with the mathematical logics. Of course, with Gödel and Hilbert and Frege and all of these people. So yeah, it's if you want an in-depth history of logic, this really is the book that you want. Next, a book I'm working towards is Physics of Atoms and Molecules. I already showed it in my last video, but that was kind of brief, so I want to do it again. So this really deals with the structure of atoms and how the periodic table basically works and how elements are constructed. You see here, it starts with quantum mechanics. It starts with one electron atoms, basically hydrogen. Interaction of two electron atoms is only in chapter 7. Many electron atoms and all the different coupling schemes. You see here radiation, to how things interact with how different atoms interact with radiation. Then we have spectra, collisions of electrons and atoms, collisions of atoms and atoms, lasers, and atoms in cavities, resonance. So this is basically a full course on everything to do with atoms and molecules and the mathematics behind them and the quantum mechanics behind them. So basically this will derive, in a sense, the periodic table, in the sense that it is possible, and it will basically show how the atoms are constructed. Here we have Classical Field Theory by Nastase, or I don't know how to pronounce it. It's a Romanian writer. It's a book on classical field theory, and it starts with classical mechanics. It goes on to rotation groups, Lie groups, scalar field theories, integrability, perturbation theory, electromagnetism, Maxwell equations. This is all extremely advanced already. So the book is fairly hard to follow. The notation is not a mathematician's notation. It's kind of awkward, and it's not an easy book at all. I really I'm working through this one right now, but I really struggle with it because it's not simple at all. It's a tough book. Then the same writer has this book on quantum mechanics, a graduate course. So this is a more advanced book on quantum mechanics, where we basically see that it starts with Hilbert spaces, finite and infinite dimensional one. You see here it deals with distributions and delta functions, so it takes all of these for granted. The postulates of quantum mechanics are next. Then it deals with position and momentum, Heisenberg uncertainty. It has the harmonic oscillator. It has the Feynman path integral. It has symmetries in quantum mechanics. It has rotations in quantum mechanics. It has perturbation theory, it has spin theory, it has basically everything you need to know. It goes on and on and on. It's a really thick book. It's really also a really nice book. If you connect, you see atoms and molecules on the end. Unitarity, Born approximation. This is really, if you can get through this book, you basically know everything of quantum mechanics that you need to know to start research, basically. Then here we have Groups and Symmetries, a very good book, but a very thin book too. Groups and Symmetries, where it deals with finite and Lie groups. It is very geared towards physics, even though there's no physics in the book. The applications are clearly towards physics, if you know. It starts with some group theory in the beginning, finite group representations, compact group representations, Lie groups algebras, special Lie groups, so now spherical harmonics. Then it has all kind of different representation. It goes into quark theory, and at the end there's spinors. So it's all mathematical. It doesn't really touch on the physics behind it, but yeah, you need all of this to do some serious physics, basically. It's all very necessary. Then here we have Brunsden, Quantum Mechanics, which is just a quantum mechanics book. Not so theoretical. It is a pretty nice book, and it's pretty advanced, but not so mathematical. It's more to the applied side. You see here it deals with perturbation theory, approximation theory, Schrödinger equation. It deals with collision theory. It deals with relativistic quantum mechanics in the end. And yeah, it has a lot of stuff on quantum mechanics. Basically, it's good for grad course on quantum mechanics, but maybe not from the most mathematical pure point of view. Next here is Marsden, which is a book on manifolds, tensor analysis and application. It is a book on manifolds, but it deals with manifolds in the most advanced point of view, meaning it starts straight off with topology and Banach spaces. It does manifolds on Banach spaces. It does tensors, vector fields on Banach spaces. Integration on manifolds, Stokes theorem, all on Banach spaces. And in the end, there's some very cool applications on Hamiltonian mechanics, on fluid mechanics, on electromagnetism. But yeah, this is like, Marsden is like a very rigorous writer, and everything is mathematically very sound. This is all very applicable to classical mechanics, but yeah, it also deals with things in the most rigorous version possible. If you're interested in rigor, if you're interested in function analysis and manifolds, this is definitely the book you want to do. But it's also a very tough book. Not the easiest exercises out there. Then we come to a book I like on linear partial differential equations and Fourier theory by Pivato. And it deals with the usual suspects in partial differential equations. So it deals with the heat equation, the wave equation. It deals with the general theory. It deals with Fourier series in terms of partial differential equations. Then it deals with boundary value problem, the Poisson problem, the Dirichlet problem, Bessel functions. Yeah, basically everything that you need in a partial differential equation course. The book isn't the most rigorous one. It's very applied. It's a very applied focus. There's a lot of application in this book. You see a lot of links with physics. I think this is exactly what a partial differential equation course should be. But if you're interested in applications, if you are interested, if you're interested in theory rather, in pure math, if you're interested in proofs, in abstraction, then this is probably not the book that you want to be doing. If you're interested in applications, this is definitely one you should be doing, provided that you can handle the book. Then we have here another really good book, Lemos, Analytical Mechanics. It's one of my favorite books on analytical mechanics. And it deals with, it starts with Lagrangians and Hamiltonians, well, the Hamiltonian variational principle, rotational motion, rigid body motion. Then it goes towards small oscillation theory, relativistic mechanics, Hamiltonian dynamics, canonical transformations, Hamilton-Jacobi theory, very important, and how it appears in quantum mechanics. And then finally it ends with classical field theory. And yeah, it's physics books, of course, but it's mathematically okay. I'm not going to say it's the most rigorous book, but it's mathematically okay. I like the book a lot. It does a lot of examples. It does a lot of theorems that are very interesting. And I think after a book like Taylor or Gregory or like an undergrad, but upper level undergrad classical mechanics book, this is a really nice book to go through. Really beautiful written book. I'm already quite towards the end of the book, and I've worked through almost every single problem, and it's very nice. Very good problems, very good set of problems. Then we have here, I think, the ultimate book on quantum mechanics, Eisberg and Resnick. Yes, it is the same Resnick as the trash Resnick, Halliday Resnick, but this book is really good. This book deals with quantum mechanics on a very application-based but level. So it has the blackbody radiation, it has photons, it has the Bohr model of the atom, and it really derives everything in a way that I like. It has Schrödinger's theory, then it starts with the one electron atoms, it has spin statistics, it has multi-electron atoms, it finally goes towards molecules, solids, then it has nuclear models, nuclear decay, elementary particles. So yeah, it really covers a lot of quantum mechanics. But yeah, it covers it in more depth than the usual books on that level. So this is really an undergrad book, maybe a lower level undergrad book. But it covers it much more in depth and much better. It really shows where everything comes from and why we should really care about these things. You really want to be able to handle the book before you get the book. It's not a book that you should get for your first encounter to quantum mechanics.